Hello everyone. In this video, I will be talking about a topic called as backtracking. This is with respect to the subject analysis and design of algorithms. The subject code is BCS 40. In this video, I will be talking about backtracking and three common problems that come under backtracking: N-queen problem, Hamiltonian circuit problem, and subset sum problem. Okay. So before we go to backtracking, let us understand why these many techniques are present and why backtracking is so important. See, when you design an algorithm, there are two things that need to keep it in your mind. One is the time complexity, the other one is space. Time complexity means when you design an algorithm, your algorithm should execute in minimum amount of time. The other thing is the algorithm that you design should take up minimum amount of space. So while keeping these two in mind, there are so many different algorithm design techniques that we know of. One such technique is called as backtracking. See the definition over here. Backtracking is a more intelligent variation of exhaustive search. Exhaustive search means, understand this, when you have a problem, you go on finding different solutions. See, when you want to find a solution, there might be different intermediate steps also. Sometimes what happens is we know that this intermediate step might not lead us to the solution, but we do nothing. We still go with that path, and then in some alteration or iteration, we are going to get the solution. This is also very similar to that. But the basic idea of backtracking is construct the solution one component at a time and evaluate the partially constructed solution. Okay. See here, if the partially constructed solution can still possibly lead to a full valid solution, we continue. If not, we backtrack, go back to the go back and change the previous choices. See here, what happens is, suppose I want to find a sum. Okay, I want to find a sum. So I will add one number 2. Okay, I will be getting 2 here. Okay, let's say I want to find the sum as 20. Okay, some value should be 20. So first I will add that number called as 2. Then let's say I have added a number called as 5. Okay, so here the answer is 2. Here the answer 5 plus 2 is 7. Next, if I add a number called as 20, so I will get the answer as 27, right? Now you see that the answer I needed to get is 20, but the number I'm getting is 27. So what happens in backtracking is, if this solution is not a valid solution or this is not going to lead you to a correct solution, then you go one step backwards and check for other possibility. That is backtracking. If the solution is not going to lead you to the ultimate solution, when you're doing answer, there might be some intermediate steps, and one of the intermediate step, if it is not going to lead you to the correct solution, you don't consider that step at all. You go back to the previous valid step, and from there you choose another alternative. That is backtracking. So in exam also, if they ask, so how are you supposed to write? So tell like this, okay, backtracking is an algorithm design technique in which, while considering the solution, ultimate solution, we are constructing one component at a time. And if a given component is not going to lead you to a correct solution, then go back to the previous step, which was valid, and from there go to another alternative and check if it is going to lead you to the solution. This is called as backtracking. And see here, I have also given how it works. Okay, so this, if you read, you should be able to understand. See how it works at each stage. If a valid next component exists, add it to the partial solution. Okay, if there is a step, and when you do the next step, if it is going to lead you to the solution, so this also will become the part of the solution. Okay, if it is no, if the valid option is, the next option is not valid, backtrack to the previous step and try a different option. So for example, I have included 2 and I have got this answer. This is correct. Okay, what happens is, suppose I have the solution like this, partial solution, and I will add one component called as 3, and I'm getting this intermediate one more solution, which might not lead me to the correct answer. So what I will do is I will go back to this part, and from here I will try to choose another alternative. That is a that is how backtracking works. I hope you have got the point. And when you're talking about backtracking, there is something called as state space tree that you need to look at. See, it is a tool for, first let us understand this. It's a tool for implementing backtracking. It's a tree, so you should know that there are roots and there are child nodes and all that. The root represents the initial state before searching, and there is first level, there is second level, there is promising node. See, this one is very important. You should understand this. What is promising node? A partial solution that might lead you to the complete solution. Non-promising node means a node or the solution that cannot lead you to the complete solution. See, suppose if I have these three numbers, okay, 2, 3, 5, and I want to get the sum as 8. So if I add 2 to the solution, it looks promising, right? I might get the answer as 8. So promising. Next, 3. When I add this, I will get the answer as 5 because previous solution is 2. So for that, I'm adding 3. Okay, so it is giving me 5. Next value that I have is 5. So I will add that. Now you see, I have got the answer 10. I should have got the answer 8, but now I have got the answer 10, which is not the correct solution. So what I have to do? I have to go back. So this might be a promising node because we are not sure, right? 5 is there, 5 is less than 8. So if I add another component, it might lead me to the correct solution. So this is called as, this is called as a promising node. Whereas when I got the answer 10, I know that answer 10 is not going to lead me to the correct solution. I wanted 8, I got 10. So 10 is not going to lead me to the solution 8, right? So this becomes a non-promising node. So state space tree means there would be a state and the possibilities are there like this. One possibility might be a good possibility, a promising possibility, or sometimes it might not be. So you choose another alternative. So it is going to look like a tree itself. And I hope you have understood this about state space tree. Now let us look at the three problems that come under backtracking. The first one being n-queen problem. Very important problem from the exam point of view, okay, and even the placement point of view. See, the idea is the queen's problem is to place n queens in an n cross n chessboard such that no two queens attack each other by being in the same row, same column, or same diagonal. See, suppose there is n queen. N queen means there will be a chessboard. You know chessboard. Chessboard is like a mix of boxes like this. Okay. So you have to place these n queens one after the other, making sure that if you're placing, suppose I placed a queen here, then it cannot, the next queen cannot be in the same row, same column, or in the same diagonal. So the possibilities, next queen can come here, here, or here, like this. Okay, so n queen means n cross n chessboard. So if there is 3 queen, that means it is 3 cross 3 chessboard. If there are 4 queens, it's a 4 cross 4 chessboard. That means total boxes would be 16. Okay, now let us look at some of the examples here. See, if the n is 1, that means there is only one queen. So the chessboard is also 1:1, and you can place your queen here. Might be a valid solution because there is no attack happening, but the 1 is usually not considered. Now, can you tell me why do you think n equal to 2 is not a valid solution? N equal to 2 means 2 queens. Why do you think this is not a valid solution? N equal to 2, so chessboard will have 2 cross 2, so 2 rows and 2 columns. So suppose I place the queen here. Okay, so next queen can't go in the same row, same column, and same diagonal. So next row, no possibility is there. So this is not a valid solution. So when you have n equal to 2, no valid solution is obtained. Next, let's see when n is equal to 3. N is equal to 3. So 3 rows and 3 columns. 3 rows, 3 columns. Now let us try to place the queens. Okay, so first queen will go here. We'll eliminate the possibilities of not inputting. So here no queen can be placed, same row, same column, same diagonal. Correct? So where will be the next queen going? You have to place it row by row. Remember, you have to place it row by row. So next queen will go here. Now, with respect to this queen, eliminate the boxes in which you cannot place your next queen. So this row, this column, and this diagonal also will be eliminated. So here it was not possible, here also not possible, here also not possible. Now, there is in the next row, there is no possibility of placing the queen, right? So you can say that for n equal to 3 also, or there, when there is 3 queens, you do not get a valid solution. Let us look at the possibility of n equal to 4. N equal to 4. Okay. We'll see if the solution is obtained for n equal to 4. Remember, this is a very important question in the exam. So you have to understand this and also learn in model question paper also, in semester exam question paper also, your previous year question papers. This was one of the questions asked. You have to illustrate the 4 queens problem. Okay. So 4 queens, that means your n is equal to 4. So there is a board which is having 4 cross 4 boxes. Okay. So you will start with the board. So 4 rows, 4 columns. 4 rows, 4 columns. I'll call this as an initial state. Okay. So I'll call it as S0. Now, I will try to place the queen in the very first box. Very first box means here, okay, in this part. So I will not place it in that same box. I will go to and I'll show with respect to the next box. Okay. So next state, sorry. So what I will do is I will write, because I'm going to insert it in the first, this one, right, column. So here. Okay. So 4 boxes, 4 cross 4 boxes. So try to place your first queen. So I'll place the queen over here. Okay. So once I place the queen, I will try to find out the possibilities where the next queen cannot be placed. So same row eliminated, same column eliminated, and same diagonal is also eliminated. Understand this? Same row, same column, and diagonal is eliminated. Now, first row has got its queen. First row has got its queen. Next possibility is inserting the queen in the next row. So, identify the possibility. See, this one can't be inserted. In this one, you can't insert. What about the third box? Third box as in here. So, there is a possibility I can place it here, right? There is a possibility that I place it here also, right? So 2 possibilities are there. We'll check which one will lead to a solution. So first you eliminate the ones which are not going to see. In this row, I can't place. That means here. And here also I can't place. This is a possibility and this is a possibility. So I'll take the next chance and see if this is going to lead me to the solution. So my first queen is here. I'll place the next queen over here. Now, with respect to this, let's eliminate the possibility of the queen's positions in which we can't insert. So, with respect to the first queen, this is eliminated. This is eliminated. This is also eliminated. With respect to the second queen, same row, same column, same diagonal is also eliminated. I hope you're understanding. It shouldn't be that hard to understand. Now let us see in row number 3, where can I place the queen? Okay. So let's go one by one. See this row. Okay. I'm talking about this row. See, this place is not possible. In this place also not possible. Here also and here also. Not possible, right? So we can say that here also not possible, not possible, not possible, not possible. Here you could, here, but you have to go row by row, right? So what to do now? So when I try to insert the queen in this particular box over here, the next queen in the third row cannot be placed. So what do you do? Now I've got a solution. From this, if I continue, I will not get the valid answer. So what am I supposed to do? According to the concept of backtrack, I will have to go back to the previous step. So from here, I will go back to the previous step. Previous step is this one. Okay. From here, I will have to find another alternative. So this option did not give me the solution. So what am I supposed to do? I can go with this solution, right? So I will go with that solution now. Okay. So let's take the chance over here. So 4 boxes. So first queen came here. Now let me place it over here. Let us eliminate some positions. So the same row, same column, same diagonal. This one, same column, same row, same diagonal. Correct? Now, can you tell me where you can place your next queen? Let us try to see. See, your second row is also filled. Now, third row. See, this position can't be filled. This position can't be filled. This position also can't be filled. So, sorry, here also. Where is the possibility now? This box, right? Here. You can place it over here. So, this is a valid solution. So, from here, go and do the step. Okay, so next queen comes here. Third queen. So, first queen here, second queen here, third queen came here. Again, we'll remove the possibilities of places where the queen can't be inserted. So, here, the same row, same diagonal, same row, same column, same diagonal. And for this third queen, same row, same column, and same diagonal. Now, can you tell me what will happen? Where should I place the next queen? If you're thinking you can place the queen in the fourth row, it is impossible because everything becomes a row, column, right? Or a diagonal. So, this is not a possibility. This is also not a possibility. 4 possibilities are also eliminated. So, what are you supposed to do? Backtrack. Come back here. When you came here, this was the only possibility, and that possibility did not give you the solution. So there is no alternative also. So what are you supposed to do? Again, go back to the previous step. So this was S0. So this becomes S1, S2, S3, and S4. Now, from here, here also, what did you do? There were 2 possibilities. Both the possibilities you explored. It did not give you the solution. So again, from here, what will you do? Again, go back. Backtrack. So let us choose the other alternative. So we have to come back to the initial state now. From here, we'll try to see the possibilities. See, when I place the queen over here, it did not give me the solution. So I'll try placing the queen in the second place here. I'll try to place it over here and check if the solution is, I'm getting the solution or not. Okay, so let us start. So this is eliminated. So these 3 are the possibilities. So I'll start from here. Like this. Okay. Let us try to place the queen here. Then eliminate the places where the next queen can't be placed. So same row, same column, same diagonal, same diagonal. Correct. So for the next queen to be placed in the row 2, this place not possible, not possible, not possible, possible. Correct? Because that is not, breaking any of the rules. So this is not possible here also. Fourth one is possible. So what I will do here, 1 minute, I will take the, I'll take the next option. So next option is here. Okay. So let us see where I can place the next queen. But before that, can you think of the solution? Give a moment here, 1 minute here, and check if the solution, if you're able to get it before you go forward. Pause the video and check. I will give you some time. So I hope you have figured out. Next queen comes here. Okay, from here, next queen. Okay, so you're not supposed to place it in that step itself because everything is step by step only. So this is S5, this is S6. So queen and queen here. Okay, so we'll eliminate the places again. Same column, same diagonal, same row, same column, and same diagonal. So where do you think you should place your next queen? So row number 3, this place eliminated, this place also eliminated, this place also eliminated. Only box available is here. Correct? So, okay. So this one is not possible. This one is possible, not possible, and not possible. So we'll take up the one with the possibility. So 4 queens. This is queen 1, queen 2, queen 3 will come here. Now queen 4. Queen 4. Let's eliminate the places. This one not possible. Same column, same diagonal. With respect to second queen, this becomes a row, this becomes a column, and this becomes a diagonal. Okay. Okay. So what about the, sorry, I think I might have misplaced here, right? I'll go back here because here I made a mistake. See, it should be like this, correct? So queen should come here. So this place eliminated, this one eliminated, same column eliminated, diagonal eliminated. This is also a diagonal. This is also a diagonal. So the next queen would come here. Correct? So let us make it neat. So first queen is here. Second queen is coming here. Now with respect to that, let us. So here not possible, not possible. Same column, same diagonal. This is also a diagonal. With respect to the second queen, this is a row, a column. This is a diagonal. And this is a possibility here. This third box here. So what I will do is, this is a possibility, not a possibility. Okay, so I'll try to place a queen over here. Okay. you are supposed to show all the states very clearly. Sorry, this is S6 and this is S7. So queen, queen, and queen. Now what about S7? S8, okay. So this is not a possibility. Not same row, same column, diagonal, same row, diagonal. So what to do now? This also gets eliminated. The only possibility is here. Okay, so this is not a possibility, not a possibility, possibility, and not a possibility. So I will take the next best option. So queen, 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 and see, you have got the solution. You were able to place all the queens without breaking any of the rules that were meant to be followed. Correct? So, this is your n queens problem for 4 queen. So, when the how do you define this n queen problem? You can't really define. Let us write the goal of this particular problem. There is a n queen which is supposed to be placed in a n cross n chessboard. You have to make sure that no two queens attack each other. Attacking in the sense, one queen, if it is placed, the next queen should not be in the same row, same column, or same diagonal. Okay, a very important problem that comes under backtrack. I hope you have understood. So that is the first problem. Let us go to the next problem called as Hamiltonian circuit problem. So what is the aim? Kindly read this one once. Let us read together. Hamiltonian circuit problem. Given a connected graph, aim is to find a Hamiltonian cycle is present or not. You have to find whether there is an Hamiltonian cycle. Let us see what is a cycle. Hamiltonian path is a path in an undirected graph that visits each vertex exactly once. And Hamiltonian circuit is a cycle in an undirected graph that visits each vertex exactly once and returns to the starting vertex. I will explain this with the help of an example and see the real life application. It is used in this city planning and all when you want to, create these roads and not create, sorry, construct roads. You can use this particular problem. And in cryptography also it is used and in game planning also, moving through different levels, the difficulties and all that. You can make use of this. Let us see what is meant by Hamiltonian cycle. See, the idea is, suppose I take a graph of 4 nodes. Let us make it connected. Okay, you can't keep it as unconnected. Unconnected in this sense, like one node is just placed randomly. The idea is you can start at any given vertex. You have to go through all the vertices once, exactly once. So, for example, here I have started at A. I will visit B, from B to C, C to D, C to D, and D to A. Okay, so A to B, B to C, C to D, D to A. Like this. See, this is a Hamiltonian circuit. That means you start at a given point, go through all the other vertices exactly once, and come back to the same point where the start was given. Okay. So this is Hamiltonian circuit. So very important graph problem. Let us take an example and understand how this works. Okay. So example 1. This is also a problem under backtracking. So if the solution is not correct, then you can go back and check for another alternative. So A to B, B to C, C to D. I'm taking an example just to show you how this works. Okay. And F. Let me connect it. Now, let us start the solution. You have to first identify the starting vertex. So, I'll take the starting vertex as A. Okay, you can choose any. I'll choose it as A. Let us start the solution. So, state space tree. So, I'll start at A. Okay. Then, understand this. From A, identify the next nodes to which there is a direct path. From A to which node? See, there is a direct path from A to B, A to C, and A to D. A to B, A to C, A to D. So, A to B, write it as a next valid state. So, from A, I can go to B, I can go to C, or I can go to D. Okay. Next, you take this path, this first path, and check whether it is going to give you the Hamiltonian cycle or not. So, yeah. Okay. So, I'll go with B now. Check from B, where do you have the direct paths to? From B, I have a path to C, to E, and to F, right? These are the three paths. So, C to E and to F. Okay. So, before that, let me erase all the, yeah. Okay. So, from B, I have direct path to C, E, and F. Now, I'll take this path, C, from here. From C, you have to check for the direct paths. Okay, from C, I can go to A, I can go to B, I can go to D, or I can go to E. But you can't go back to A and B because there is a condition saying you have to visit a vertex exactly once. So this is not a possibility because you have already visited A, because you have come through A only, right? From A, you have gone to B, then you have come to C. So those two can be checked. So the possibility is either go to D or to E. Correct? So you can do like that. So it is to D or to E. Again, check for the solution. So D, okay, from D I will check it. From D, now you have understood, I am hoping. So from D I will go to, from D I can go to E, C, or A. But C can't be used because C is already visited. A can't be used because that's a starting point, obviously. The only possibility we have is E. Correct? So I'll write the option as E. From E. From E, I will get the option of, from E, understand this. From E, I have B, C, and F. B and C can't be used, so F. So you have gone through all the nodes. Okay. Now you check. You have reached here. So you have gone through. From F, if there is a direct path to the source from where you have started, then it would be a Hamiltonian cycle. Okay. See, from F, there is no direct path to A. That means there is no solution. This is not the solution. So this becomes a dead end. Like this, now you choose the next alternative. So this is not the solution. So you will go back. So from here, you'll go back. From here again, you'll go back. From here, you'll go to the next alternative. Next alternative is this one. Correct. So let us see. So A, B, C, A, B, C, E is then. So from E, we'll try to check the solution. From E, the paths are C, B, F, and D. C, B, F, and D. C is already done. B is already done. So the options are D and F. Next, I will go to D. From D again, I will try to find the solution. Okay, but before that, let me erase all the unwanted information. So from E, I have D and F. So D, from D, I can go to A. You follow, you look at the problem also as well as the solution. From D, I can go to A, to C or E. But I can't go back to A. This is not the solution. C also is not a solution. E is also not a solution. So everything is, there's no other path. So dead end. Correct? It's a dead end. So what will you do? This is a dead end. So backtrack. From E, I could go to D or I could also go to F, right? So check the next alternative. From F, so A is done. A to B, A to B, B to C, B to C, C to E, E to F. From F, I'll try to see the possibilities. From F, I can go to E or B, but E and B both are already, it's a visited one, so you can't go to it. So there is no other possibility. So this is also a dead end. Okay, so again, backtrack, 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 come back to the alternative solutions to E. Okay, so from E, paths are, from E again, the paths are C, D, and F. C, D, and F. All three are not visited, right? So C, you make it neat, okay? So don't do it like this. This one, I just it's a little messy, but yeah. So C, D, and F, let's explore each of the paths. So from F, I'll try to do. So from F, is there a solution? From F, E to F, B is already visited. So from E, F is already visited. This is also visited. So everything is circuit. So it's not a cycle. So dead end here. So from here, go back. Choose the other alternative C. From C, you try to find out. From C, you can go to D. That's only possibility. Again, it's a dead end. Okay. And F, D to C. This is also a dead end. So what you will do? You will come back to this point. This point as in this B. Again, check for the next alternative. So C did not give me the solution. E did not give me the solution. Let us check if F is going to give me the solution. Okay. So yeah, from F. So I will try to erase it so that I have enough space for it. Okay. So yeah, B. From B, I could go to C or E or to F. This was previous step A. From A, I could go to C or D. Okay. So A, B to F. Let us look at the solution now. B to F. So B to F. B to F, from F I could go to, from F I could go to E or B. B is already a part of the solution. So the only alternative that I have is E. So I'll take that path, E. From E, I will try to, I'll erase everything. Yeah, I'll redraw. only the required thing. So E. So from E, see very carefully, from E I can go to D, C, B or F. From E I can go to D, C, B and F. Okay. B and F is already eliminated. So D and C are the only possibility. So yeah, I'll write it in the alphabetic. There is no order. You can write it anyways. I'll write in C and D. Okay. So from C, let us try to see from C. From C, I have a path to A, B, D and E. Correct? This one. See, I can go to B or A or D or E. So A can't be done because A is already in the path. B also can't be done. So the only possibility is D. Correct? E is also not possible because E is also visited. Okay. So from C, I will go to D. Okay. Now you see here, how many nodes are there? Total of 6 nodes. A, B, C, D, E. Not total 1, 2, 3, 4, 5, 6. See in this path, all are covered, right? A, B, F, E, C and D. All are covered. So now what you can do is, once you have covered all the paths, the last vertex that you have got, check from there whether there is a direct path or not. So we are at D. From D, is there a solution to A? The starting vertex? Yes, there is a solution. So you can say that there is a formation of a Hamiltonian cycle. You have to start at a given vertex, visit all the vertices and come back to the original position. If it is possible, if you are able to do that, then you can say that Hamiltonian circuit is present. Okay, so this is a solution. Can you do this one? Can you do for D? Okay. From D, again you have a path called C because all the other paths are visited. Now, once you have visited C, everything else is visited and you have a direct path back to A. Correct? So this becomes a solution. Other paths also you can explore, but once you have got 1 or 2 solutions, you can stop. Now you might wonder, where should I stop? Once you get 1 or 2 solutions, you can stop, because this problem, because it is backtracking, there are so many different possibilities. You can just go on. Okay, you need not do everything. Let me do one more problem related to this. I'll do like one solution. Okay, so A, B, G. You have to pay attention because this time I will not draw anything. I will just, go on telling the information. So you should be able to concentrate and you should be able to listen properly. Then only you will understand. So I will start at A, my starting vertex. Its neighbors are B, E, E and G. Okay. From A, I have path to B, E and G. From B, let us try to find. From B, I can go to E or C. Correct? From B, I can go to E or C. So, yeah. C or E. From C, I can go to B or E. From C, I can go to B or E. E is already, A is already visited, so the only possibility is, so B is already visited, so the only possibility is E. From E, I have visited all the vertices. So 1, 2, 3, 4. From B, I can go to G. From E, I can go to G. And from G, I can go back to the original point, that is A. So in first step itself, I've got the solution. What about the next one? E. From E, the possibilities are G, B, all are there. Okay. But A and B can't be visited. So the only possibility is C and G. From C and G, C and G both become dead end because everything else is visited. So this becomes dead end. This is also dead end. Similarly, I'll take one random now, G. Okay. From G, I will take the possibilities. From G, I can go to, from G, I can go to E. From E, I can go to B or C. If I take B, I can go to C, but this is a dead end. What about the next possibilities? From C, I can go to C, I can go to B, but again, dead end. Correct? So this is how you will do the circuit. You will have to explore all the possibilities and make sure from where you start, you end up there. Okay. That is the second problem called as Hamiltonian circuit. The third problem under backtracking is called a subset problem. See the goal. Find the subset for a given set A is equal to A1, A2 up to AN of n integers, positive integers, whose sum is equal to a positive integer D. The idea is there will be some elements in your set and they will give you some D value, set value. So let's say 10. You will have to find the subsets among these which will give you this result. How can you get D equal to 10 from these three elements? Possibilities by adding 3 plus 7. Correct? This is the result you are expected to get out of this problem. Suppose I give 2, 4, 6, 8 and I give the D value as 10. How am I supposed to get the solution? One possibility is 4 and 6. That will give you 10. The other possibility is 2 and 8. So if you give these two things, this should be the result that you are supposed to get. I hope you have understood. That is your subset problem. Now let us do one problem so that you will be able to understand. Okay. Let me take the most simple example. Okay. Let me take the set S as, I'll take this as example 1. So I'll take 1, 3, 5. Let me take the D value as 8. So I'm supposed to get 8. Okay. I'm supposed to get 8 by mixing these three numbers. Some combination you are supposed to get, some subset. Okay. So initially, again, state space diagram. So initially in this case, put it as 0. No value is included. Next, try to find the solution by including one element at a time. Find the solution by including one at a time. So first it would be with the first element, that is 1. I will include this first element 1 and I'll try to get the solution. So solution, if I add 1, so 0 is the initial value. If I add 1, this will become 1 itself, right? And 1 might lead me to the solution because it is still lesser than 8. If it is greater than 8, not possible. But if it is less than 8, I might get the correct answer by including the next component. So what I will do, I will go ahead with the solution. Okay, so without we will look at later because now it is giving me the promising notes, no? So I will go ahead. I will try to include the next solution. So next element. So with the 3. With the 3, how much is the solution I'm getting? 1 is already there. If I add 3, I will get the answer as 4. So 4 again might lead me to 8. So promising solution. So let me try to include the next value. So with the 5. With the 5. With the 5 if I do. So if I include 5. So 4 is already there. 5 is my number now. So if I add, I'm getting 9. And no more elements to be added. Did I get the solution? No. I have come across a value that is greater than my value of t, which is greater than 8, right? So which is greater than 8. So I can say that I have reached the dead end. Now what to do? Dead end means, so when you reach the non-promising node, go back to the previous. So go back to the previous means here. Okay, you need not show it, but you should know that where you're going. Okay, so with the 5, I did not get the solution. So I will go back and check without 5, am I going to get the solution? Without 5, that means 4 is already there. Without 5, what will I get? Without 5, I will still get answer as 4 itself. No more nodes to be, no more elements to be added. So 4 again is not 8. So again we have reached the dead end. Now, what are you supposed to do? Backtrack here. You have checked all the possibilities. So backtrack here. With the 3, you tried the solution. Now you check without 3. Another alternative. Okay. So here. Without 3. Without 3, what is the answer you will get? Without 3, you will get the answer as 1 itself. 1 was a solution. Here, partial solution. So without 3, I am getting 1 itself. Next, without 3. So next, with 5. Try to include the next element. 3 not possible means let's check with 5. 5, I will get the answer as 6, right? 1 is already there. Element is 5. If I add, I will get the answer as 6. But is 6 equal to 8? No. 6 is, your D value is again not getting fulfilled. So you can say that 6 is less than 8. Again, dead end. So without 5, we'll check. It will not make sense because 1 is already there. Without 5 means again it is 1. So what do you do now? Backtrack. So from here, you will go to this point. From here, at this point, you have checked all the alternatives. Nothing was working out. Shall go here. Again, here also at 1, you have checked all the 2 possibilities. No. So you'll go here. Again, now with the 1, you tried to do the solution. You did not get. Now you will check the other alternative, that is without 1. So without 1, I'm getting the answer as 0 itself, right? Because 0 is there. I have not included 1. So 0 only. Next, let's try with the 3. With the 3. With the 3. So 0 plus 3 is 3 itself. Next element. So 3 is still a promising node because it is less than 8. And I have still more nodes to be added. That is very important. Okay. Next, with the 5. With the 5, what is the answer I'm getting? 8. Now you check. D was supposed to be 8. I'm getting the value 8. So I have got one solution. This is supposed to be a dead end. This one is less than 8. But this is a solution. This is a solution. How did I get that? By taking this path. That is without 1, with the 3, and with the 5. Suppose I take this as 0, 1, 3. So I did not include 1, 1. So I'm giving value 0. I included 3 and I included 5. So 0, 1, 1. Okay. I hope you have understood. Let me do one more example. 1, 2. This time I'll do it slightly faster. Sorry, 1, 20, 20. Let me write it neatly. 1, 20, 25, 30. Let's say the D value is 55. So initially 0, then with 1, so 1, next element with the 20, So 21. Next, with 25, I'm getting the value as 46. 46. I'm getting, I'm supposed to get 55, right? 46, okay. So with the next element 30, so 76, which is greater than my expected value. So not a solution. So I will backtrack. So I will come back here. So without 30, I'm getting 46 itself. So not a problem. Come back to the previous solution. Without 25, I will check. Without 25, it is 21 itself. I'll add the next element with the 30. 51, not a solution. Without 30, it is going to be 21 itself. So backtrack, come back here. Without 20, not a solution. So 1 again with the 25, 20, with the 25, 26, with the 30, 56, not a solution. So come back without 26, 20, without 30, sorry, without 30, 26, come back here without 25, 1, with the 30 and without 30 also, I'm not going to get the answer. So I'll come back here. So with 1, I did not get. Let me try without 1. So without 1, I'm getting the answer as 0 itself. So I will include the next solution with the 25, 20, sorry, 20. With the 20, answer is 20 itself. Looks promising. So with the 25, it becomes 45. Next, with the 30, how much is it going to be? 85. Not a solution. This is also not a solution. We're supposed to write dead end. So without 30, again 45 itself. Without 25, I'm getting the answer as 20 itself. So I'll include with 30. Getting the answer as 50, not the correct answer. Without 30, I'm getting the answer as 20. So I'll go back. With the 20, I did not get the answer. So without 20. Without 20, 0 itself. Next, with the 25. With the 25, answer is 25 itself. 25 again with the 30. So I'm getting 55. You see here, I have come to the solution. See, D is equal to 55. This is the solution. How did I get that path? How did I get that path? By going to this path. See, so it went like this. See, without 1, without 20, with the 25, with the 30. So you had elements 1, 20, 25 and 30. So you did not included 1, you did not include 20, you only included 25 and 21. Sorry, 25 and 30, which gave you the solution. So this is subset problem. You are supposed to backtrack, go back to the previous step and then do the solution. So in this video, let me recall all the things we have learned. We had learned about backtracking in this particular video. That is algorithm design technique where we design the solution one component at a time. If the component that we have got leads to the good solution or an optimal solution, then continue. Then that node is called as a promising node. And wherever you have got the solution and that solution is not looking like a one which is going to lead you to the final solution, then that is called as non-promising node. In that backtracking, we also saw something called a state space tree. State space tree looks like a tree where there is a root which looks like the solution, and its child nodes might be the two alternatives that you might have to explore in order to get the solution. And under backtracking, we also looked at three problems: N queen, Hamiltonian circuit, and subset problem. Go through all the three methods, take up your own examples and try to do the solution. Let me recall N queen. There will be N queens with the N cross N chessboard. You are supposed to place the queen in such a way that no two queens attack each other. That means no two queens in the same row, same column, and same rank. Then we came to the Hamiltonian circuit where you will have to find whether there is a Hamiltonian cycle present or not. Hamiltonian cycle means we start at a given vertex, visit all the other vertices exactly once and come back to the original vertex where we have started. Okay. And there is subset problem. That is, there will be some elements given in the set and you will have a value that you will have to fulfill by doing the combination of these elements. Okay. That is subset problem. Go through all the problems, go through some of the solutions, take up your own examples, do the solution. Okay. Usually you will be asked to write the, or sorry, not write the, you will be asked to write the solution for a given problem. So you should be able to do that. Okay. Rarely they will ask you the lab program. Lab program might have been discussed already, I hope. So n-queen problem, sometimes the functions will be asked, even the subset problem function also. So you learn that algorithm for subset as well as for the queens. Okay. Thank you so much.